We're about to follow a journey that happens inside of you, thousands of times a day, yet you probably almost never think about it. We're going to trace the path of one single breath. It's a process so perfectly engineered, so 100% accurate, that it's just easy to take for granted. So let's dive in. Go ahead, do it with me. Take a deep breath. In and out. You feel that? That one simple act just set in motion this incredibly precise cascade of events inside your body. So where did all that air actually go? And what did it really accomplish? Let's trace the path and find out. Okay, so before we follow the air itself, we need to understand the architecture it's traveling through. And I want you to think of your respiratory system less like a simple set of organs and more like a high-tech biological delivery system designed with just unbelievable precision. The whole system really boils down to three core components. First, you've got the airway. That's the whole network of passages. Second, the lungs themselves. They're the central hub of the entire operation. And finally, the muscles of respiration. That's the powerful engine driving it all. Each part has a vital role in this totally seamless process. And right away, you see this fascinating little detail, a kind of purposeful imperfection in the design. See, your lungs, they aren't symmetrical. The left lung is actually smaller, with only 2 lobes instead of 3. And why? To make room for your heart. This isn't some flaw. It's a brilliant piece of biological engineering for maximum efficiency in a very crowded space. Okay, the stage is set. Let's follow that breath as it starts its journey into the body. And this path isn't just some simple pipe. It's a really complex filtration and conditioning system preparing the air for the critical mission that lies ahead. So, air first enters through the pharynx, where this clever little flap called the epiglottis acts like a traffic cop, making sure air goes down the right pipe and food goes down the other. From there, it's down the trachea, or windpipe, which then splits into 2 main bronchi. These then branch out, kind of like a tree, into countless smaller and smaller bronchioles, leading all the way to the final destination, millions of tiny little air sacs called the alveoli. Have you ever wondered why you don't feel your lungs, rubbing against your ribs with every single breath? Well, the secret is this thing called the pleural membrane. The fluid between its 2 layers acts as a perfect lubricant, allowing your lungs to just glide silently and effortlessly inside your chest. It's amazing. All right, we've followed the air all the way to the end of the line. And now we're going to zoom in, way in, to the microscopic level to witness the entire purpose of this journey. This is where the real action happens. This is the great gas exchange. Just look at that number, roughly 150 million. That's how many of those little alveoli you have per lung. All those tiny air sacs create a surface area that's so vast it's hard to even wrap your head around. And this massive scale is the key to making your breathing so incredibly efficient. And here's the beautiful part. The core mechanism here, it isn't magic. It's a fundamental law of physics called simple diffusion. The oxygen concentration is super high in your lungs and low in your blood, so oxygen just naturally moves across. The exact reverse is true for the waste gas, carbon dioxide. It's this elegant, totally passive system that requires 0 extra energy from your body. It just works. So the oxygen made the jump. It's in the bloodstream. But its journey is far from over. I mean, not by a long shot. It still needs to be delivered to trillions of cells all throughout your body. So let's see how that amazing delivery service works. Turns out there's one dominant player in this whole process. Well, a tiny 3% of oxygen just kind of dissolves directly into the blood plasma. A whopping 97% hitches a ride on red blood cells. They latch on to a special protein called hemoglobin, which basically acts as the dedicated oxygen taxi service for your entire body. But this is where the system's incredible precision reveals a critical vulnerability. As this quote points out, our little oxygen taxi, hemoglobin, it has a fatal weakness. It's 250 times more attracted to carbon monoxide, or CO. That means if it has a choice, it will pick up that dangerous imposter over oxygen every single time. So what happens when you're exposed to CO? Well, it hijacks your entire oxygen fleet. The CO molecules, they bind to hemoglobin so tightly that they just refuse to let go, leaving absolutely no room for the oxygen your cells are desperately screaming for. The whole delivery system just grinds to a fatal halt. We've followed oxygen from the outside air all the way to ourselves, and now we've finally arrived at the last step, The ultimate payoff. I mean, why do we even need oxygen in the first place? It all comes down to creating something called ATP, the universal energy currency that literally powers life itself. You see, your cells have two main ways to make energy from food, like glucose. There's the anaerobic path, which doesn't need oxygen. It's fast, but it's super inefficient. But the aerobic path, well, that one absolutely requires the oxygen we just delivered, and the energy payoff, it is astronomically higher. So every cell starts with this process called glycolysis. It splits a glucose molecule and makes a tiny little profit of just 2 units of ATP. It's a start, yeah, but it's not much. And without oxygen, this is where the energy production line stops. But with oxygen, oh, the difference is staggering. That same single glucose molecule now yields up to 38 ATP. This is the payoff. This is why we breathe. This massive surge of energy powers everything you do. Your thoughts, your movements, your heartbeat. It all hinges on the incredible journey of that single breath. And this entire complex process, it's not a one-time thing. Your body needs that constant supply of energy, which is why a typical adult runs this whole system somewhere between 15 and 25 times every single minute of every day. It's this constant rhythmic process that sustains you moment to moment, and you never even have to think about it. So the next time you take a breath, maybe you'll remember this incredible journey. Your body performs this intricate, perfect process over 20,000 times a day without a single conscious command from you. Which leaves just one final question, right? What other invisible miracles are powering you right now?